Okay, it has been a very, very long time since I have streamed. However, the admin work is over, so now I can get back to actually programming. So last time we successfully fixed our RISC-V assembly program that draws disks, and we got this running. And so now, also what we did last time was to begin to try to get textures rendering in Brevis. So to do this, what did we do? We started playing around with the, we wrote something in Zig that exported a sprite to, this is right. We wrote this Zig program that read in a QRI file and just output a bunch of this is the actual decoder, and output this Brevis tile, and then the aim is that we're now going to ingest this into a kind of Brevis, use the data in here to render something to the screen. And what was rendering before was the what's the only image viewer that actually doesn't blur pixels when you go into them again? It was Zig. It was like Zig image viewer. Yeah. Yeah. We basically want to render this to the screen in Brevis, and so we've now. This here is just like a matrix of all of the U32s that represent all of these pixel values, and now we want to get them to Brevis. I realized since working on this last time that it would actually be better to access all of these in a linear array. This way, this is because eventually within Brevis we're going to just be providing a decoded sprite file like this, which is just like a list of U32s, and we're just going to read them. There's going to be a pointer to that. We'll pass that point in Brevis to like render stuff to the screen, and we won't actually, we'll let the implementation details of the image function itself like do the correct number of loops. There's no need to go this far with the data structure. And so the first thing I want to do is just like adjust this so that it actually outputs the version of the thing that we want. Yeah, so in particular, instead of like variable 25 by 25 sprite here, we really just want 25 squared, which should be 625. And then, yeah, and then, so yeah, let's just, we'll work on getting this correct. So I think now instead we'll want to have we want sprite dereference and then just a single number, where this number is 25 times I plus the j, and then the actual value of it, which should remain unchanged. Okay. We'll over here. Okay, so now if we do just sig run roof, yeah, this is what we wanted. And so now we can now save this. So let's save this as like Brevis, or like roof sprite Brevis export. I guess we can leave this as a .txt for now. Honestly, the easiest way to copy this is just this. Okay, and now we can try and get this onto the Brevis. So let's just think for a sec. We want to make some really basic, we want to just take the default rectangle drawing function program on the Brevis, kind of insert this into it, or rather wrap all of like we'll have a global that is this variable sprite, and then we'll just make a procedure that fills this up with information. In particular, this runs through all of this once. And then once we have that, we'll then write a very simple procedure that then draws this to the screen. Okay. So to do this, we'll need to turn off power to the Brevis. I'll get rid of this, and then and we'll need to insert the SD card and just transfer the file. And like presumably the file will transfer over, but I guess we'll see. So let's like move it. Oh, but the Brevis doesn't really have a move command yet, so we'll move it. Oh. Where in this drawing experiment should we put it? This looks like the productor, so this must be the codex. So let's move it. Where do we want to move it into here? I think it's fine for now if we move it in here. We can then just copy the data as needed later. Okay, so let's send this. This is what we wanted, yeah. Okay. So check that, put it back into the Brevis. Also, what's the stream quality like? Is it? Why is the frame rate drop so bad? I don't understand. I do not understand. It's woeful. Okay. Okay, and now let's render this to the screen. So we're going to the risk V drawing experiments, the codex. Yeah, and now we have this roof sprite Brevis export. Let's make sure we can actually still see it. Voila, we can. Great. So, yeah, let's put the macro on the A. Hang on, this is read only. So yeah, what should be our next task? I think we can just clone the disk and delete stuff as needed, and then yeah. So and then we'll copy in the stuff. So let's do makefile texture dot lbc. Now let's do a file copy from the disk to the texture. Now you can just immediately edit the texture. Okay, and now we want to delete most of the code from here. So we're not doing our inline assembly disk draw anymore. We still need the setup. We don't need the vast majority of this code. There is no disk that we're animating here. We still need to start the frame, get the micros. I don't actually know what this procedure does. I think we've looked at the start frame before, but not this one. Yeah, draw a rectangle, and then we can get rid of this. Okay, save that, suspend it. Let's just make sure this compiles, and then we can get started on the copying of the texture information. Codex. Risk V. We're going to have to make a file in here. So let's do texture dot pb. Now we want to do compile given the entire directory. Given all the codecs, jump into texture dot lbc and write the output to productor texture. This is good. I remember when I first started using this system, even compiling something like this. Like the last minute took me 10 minutes. I now know it. And let us confirm that it runs. And I think this is what we expect. We just wanted a dark screen that's dark gray. So great. That is working. So yeah, now for the copying time. So let's also go into the risk V drawing experiments. And now we want to edit, or rather open our, what was it called? Open the roof export. And then we'll copy this stuff over. Assuming the editor will be able to copy all of this over, though it's not that huge of a file, so it should be fine. Hang on, shift. Okay, that's been copied. Now we can quit. Jump to 1. And then I feel like we should just paste this at the very bottom. Okay, that seemingly did that. Good. So let's set up. Let's set up this global. Put it here. Globals. I feel like this should be within like constants. Let us not forget the macron on the. And then we'll wrap all of this in a function that inits it. So let's just call this init sprite. Oh no! Oh damn! There has to be a semicolon on each of these. We're going to have to re-export the zig file. That is annoying. Alternatively, we can start to get this working. Let's like draw a modest number of pixels first, like 5. That's right. Where's the semicolon key on the QWERTY keyboard? And then yeah, we'll just get these rendering. Then later on we'll like redo the actual proper zig export. Get that working. So yeah, so we want to say we've got our procedure. I forget what the Peregrina does. I think like maybe procedure nude main is this would be fine. And then not that it actually matters in this case. I kind of want to do that. Then we want to call it. So, but we want to init this before we really do anything else. Init sprite. And then let's draw a couple of pixels in this. How are we gonna write a loop when we don't have the source code for one? This was like an exam. So let's say we want to say we want to have a done loop. Actually, we don't need a loop at all at this stage. Well, feel like I shouldn't have deleted all of the previous code. So yeah, how do we modify this pixel buffer again? So we do like one of the fields in frame is like frame.pixels. It's like a pointer to the beginning of the frame. So I think we want to just say this is a good test of what I've learned so far. So let's just say like pixel pointer is equal to this frame dot, I think it's frame dot pixels. And now we simply want to say dereference this. And let's draw this like in the center of the screen. Well, let's just draw this at like pixel 1000. Now I just want to say this is going to be the sprite dereferenced and make that 0. And we'll just do some copy pastoring here. I think all of these are the same, maybe all of these are the same color anyway. We'll figure out the DOM loop correctly next time. And then let's try and compile this. Not possible to form index operation on type N32. But I said this is a pointer. Whatever the case, I think we can close this kind of tab. What is it? Control Shift Q? Or not? Let's just copy in the correct stuff. Script M, it's read only. Do we want the disk? Yeah. So it was frame.pixels. So why is this failing? Is it that we want to is it because we're dereferencing it before the array operation? That would seem a bit weird. Because for memory it didn't matter. Yeah, what's going on? If it's a pointer, why can we not just jump forwards? Let's check out like the source code of the diamonds, because at least that was... It wasn't rendering what we wanted, but it was rendering stuff. This also has our dumb loop syntax. So this is an at M32, and then oh, we weren't like using an index on it? That's weird. Interesting. Okay. Okay, so let's copy this and modify it. So we'll just have our say like render some of the texture. So I'm going to say done. Start off with an x64. Set I to be 0. Get I is less than 5. I need, like every stream I say I need the Dvorak keyboard, but it's true. It's so true. Okay, and then we'll say like let's like reduce the typing by saying pixel pointer is equal to a frame dot pixels. But we need our like prolata statement so that we don't have an infinite loop. Let's not forget the semicolon. And then I suppose we'll just want to define like a different, maybe I for like initial pixel pointer. One that actually represents what we want. So now we can say we want our pixel pointer to be equal to the initial pixel pointer plus the I once we've casted. And now I think we want to say pixel pointer dereference is equal to sprite I, or rather sprite dereference and that kind of should be it. So okay, let's try and compile this. Huh? Let's like clear this in case. Oh, I think right. We're not using the Odin casting syntax in Brevis. We're using the Brevis casting syntax. In Brevis, you need to put parentheses around the type of your casting, not the thing that is getting cast. And that's how you avoid saying ridiculous things like caster and castee. Like, I don't, like, no one understands the difference between these. They're so confusing. Okay. I don't know of anything that's called sprite, but we define this at the top. This one we did. There's a global called sprite. Why does it not know what that is? Something feels really wrong. Is this another compiler bug? Why does it have no idea what that is? Am I getting the syntax incorrect for global variable declaration? I didn't think so. We can just check it. If we went to, let's say we went to our Sokoban, which has plenty of globals. Let's say we opened in read-only mode our source for that. Is it not just variable type name? I mean, that looks fine to me. I thought that's what I was doing. Is it a spelling error? That would be so annoying. And now this feels like it's crashed. Yeah, the keyboard is now unresponsive. Let's reboot this. So much spam on Twitch. It's so annoying. At least I'm remembering how to block the people. Are you serious? Okay. Why is it the OBS? Why is this? Is it the cap? Oh, maybe it's the capture utility that failed, not actually. Not the Serenum. Okay, let's just destroy that and launch it again. What does it mean? It is already running. So bad. I've already launched that again. Why is software today so bad? I mean, anyone using the Serenum knows why. Are you serious? This is so pathetic. Legato is just, they obviously make terrible software. Can't even handle 800 by 600. What's a way around this? Even though it was apparently before it wasn't showing. Apparently it's not able to display this device, even though it's worked every other stream. Let's try. What should we try? I wonder if we could actually plug this. I could try plugging this directly in. Let's see if OBS can add this. Video capture device. Okay, apparently, yeah, apparently you can do it. so bad. It's so bad. Yeah. Like now the resolution is going to be whack, but I know if we go into when we go into the drawing version of this, it is actually 1080p. So if we jump into like this and then the codecs and then launch this here. Let's now get rid of this. Okay, and now it's working. Problem solved. Whoever designed this at Elgato, whatever summer intern designed that. Performance review needed. Okay, so now we're gonna do. What even were we doing? We were wondering why the script or why the sprite isn't compiling. So you want to go into texture, and then no, I'm really confused as to why the compiler does not know what that is apparently. We're spelling it in the correct way. This, like, I don't know what I'm missing. Surely this is a compiler bug. Let's like turn this into a minimal example. We can get to Sam. So yeah, let's do make file global bug.lbc. Let's edit that. And we'll figure out some workaround. So yeah, this is so weird. Let's like let's just get rid of as much stuff as we need. This itself, it won't know it. So let's just say like, let's call it that. Okay. So what was that? Global bug.lbc. So now we want to say make file in the productor global bug.lbc. Let's try and compile it. Yeah, and it has no idea what it is. Although the pixel pointer here, this is an issue. It should have known what that was. Did we? I guess we deleted too much. Script it. M32 a pixel pointer is equal to a frame dot pixels. Save. Compile that again. Later. Yep. Okay. Yeah, we'll send this off to Sam later. Okay. In the meantime, this should be reproducible, but just in case, we can easily take a screenshot. No, we just want a photo. Okay, so how are we going to work around this? Maybe this is an even more difficult question. Also, how much time do we have? I'm going for nearly an hour. Okay, potentially the compiler is actually going, oh, but like when you say sprite here, this is meant to be something that's like, it's meant to have like type N32 instead of an N8. And so perhaps the compiler is just like doing some kind of type inference and not knowing what it is. I suppose this could be adjusted if we actually call this like an N32 instead. So then maybe up here we say sprite. We now say sprite 0 is equal to hold on there. Let's make this like a blue pixel, ff00ff. We'll see what happens now. No, yeah, what? This makes no sense. This makes 0 sense. Let's just try and move it from something that's global to something that's local then. Let's say I declare it here. Is that gonna work? No, this wouldn't really like it. The entire point of saying variable here is making it global. Can we at least define an array like that? Also, why am I modifying the thing that's meant to have a bug? I feel like it would be more sensible to make a copy of this and then try and fix it. Since there is no version control, obviously. Yeah, let's do this. Oh, I've already got this working up here. We'll keep this in here just as a reminder once we get this working to send it the bug report. But yeah, what was this error? Trying to dereference non-pointer time. Since it's no longer a global, okay, that makes sense. In which case, I just want to have that being rendered. what? Deficit ad fermiato. The immediate is out of range. Assertion failed. Okay, in either case, we should be. This itself feels like a more serious bug, actually. Okay, we'll submit this one to Sam as well. Like, is this array type too large? I wonder. So let's copy this. Make file. Yeah, compiler. Compile a crash 1.lbc. File copy. Global bug. Compile crash. And then we'll get another photo of this. Okay, I'm kind of astonished that we haven't run into these issues before. Okay, let us continue editing this global bug file and see if we can get it to work. So I wonder if it's because this array is too large. Like, let's say we made this a very modest size. And then we just said, dereference the pixel pointer, set it to that. Let's compile. Okay, that seemed to do it. So yeah, it seems we can't define A static array that's that large. Are you serious? How are we meant to render a texture in the game? Like bootstrap our way to writing the code for that, since we don't even know how to read a file in Brevis yet, if we can't even do that. This is what we want, right? Wait, why am I like, why is there something in productor called global bug libc? That's not correct. Okay, we need to change this. Let's go to the productor, make file, global bug.pv. Presumably we can remove files like this, remove file, global bug.lbc. Now we can call compile to compile to that. Okay, now we have productor bug. Okay, that's the, well, I don't see a pixel that's of the color we wanted, but it's not crashing. I guess that's a positive. What if we had like a DOM loop and we just drew a line instead? So we could say DOM. Let's say we had an x64 that started off as 0, and we're going to continue this loop until so I is greater than 20. Each time we're going to increase I by 1. And well, actually, we're also going to increase the pixel pointer by 1 each time. Pixel pointer and now we just declare that we call this. We'll just draw a line because I wasn't seeing a line. Yeah, where is this? I don't see this on the screen. Is it being like rendered off the screen? Look, I'm now worried that nothing's actually getting drawn. Let's say we drew a rectangle from with like a width of 20 and a height of 20. And we made this. Oh, I think it's because the transparency is 0. That's probably why. Yeah, I think it's like the endianness and the fact that transparency. Okay. So that should be blue. And then this should then be like magenta. Okay, so yeah, that is getting drawn, but yeah, weirdly we're not, like I'm not seeing the very first line of pixels getting drawn. It's kind of weird. Maybe it's being rendered like right off the screen, some way. Oh, I suppose since we're meant to be adding by 4, maybe that's the reason. Okay, and let's like add some nice buffer to this. So let's like add like 1,000. We can go higher. Let's go like 6,000. Let's go 6,300. Nope. Where is it getting drawn? I don't see it getting drawn anywhere. What on earth is going on? Yeah, like what's happening? Does this have to do with like the sprite itself in some weird way? Like if we just say dereference the pixel pointer and set that equal to this color, so like FF00. Let's just like set it to white. And let's draw some like huge amount of this. Like let's do this 6,000 times, which is just like a band on the screen. Why are we not seeing this? Oh wait, it's not gonna like us. Type 0b instead of 0x. Okay, now it is actually getting drawn. Okay, so it was getting drawn before, we just couldn't see it for some unknown reason. I bet like it wouldn't surprise me if it's this like, wow, yeah. The Elgato is just, you know, the summer interns that wrote this code are so proficient, right? Like, clearly when you ask for this to be full screen, they're just going to clip some of the pixels because who cares about the border? It's not as if anyone could be doing graphics programming with this. This is so ridiculous. I think I paid something like $60 to $100 for this capture card, and yet the people who wrote the software can't even make like full screen mode actually like show all of the pixels. This is so pathetic. Thank you for wasting half an hour of my time, Elgato, once again. Pathetic. Elgato needs to go bankrupt and replaced by a company that's actually produce software. Okay. So now we understand what's going on. Serenum is fine. Once again, it's the Elgato that's at fault. So, okay, so now we know this. We could finally try and work around this problem of the stacked global variables being bounded by some certain size. So yeah, how can we do this? Like, what are some strategies? Like, I don't want to have some strategy that like breaks up the thing into a bunch of smaller things. It may actually just be easier to just figure out how do we read a file from, how do we read the bytes of some file and bring that into a Serenum program. And then presumably we can just, I don't like that idea though. One thing we could do is just define a procedure in here that simply we re-export the file. We re-export the QI image from Zig so that every line basically, like, we define some procedure where the procedure takes in a pointer and then memory is just like written in that pointer. So let's say we did something like procedure assign memory. And then we do, or like, it's more like fill in pixels. Fill pixels. And then here we go. This does need a pointer though. What's the syntax around arguments in procedures again? It's like N32 was quite like pointer, and then we go pointer dereference. Here's where we want this loop, basically. So let's say we do fill pixels. Pixel pointer. Comma, end of thing. And then we can just copy all of this. And here, what do we want to say? We want to say increase this pointer by 4 and dereference it to be that. Okay, let's just check this compiles, and runs, remembering that the top of the screen is getting clipped because Elgato writes disastrous software. Do this. I will eventually remember the comma syntax. Take a while. Okay, that's working as expected. So now let's export a version of the QII data into a procedure that is just all it will do is assign a value of the pixel and then increase it, and then increase it again, and then increase it again. That's all it will do. Okay. So back to the Zig program. What do we want to export? We want to say let's put it horizontally instead. So yeah, what we want is we want okay, that's way too small. We just want pointer blah equals value, and then we want pointer plus equals 4. I think we just want to do this repeatedly. So this is kind of easier actually. This is a lot easier to write. We just say pointer blah equals value new line, then pointer plus equals 4 new line. This way we only need one value of that, and that's kind of it. So let's see, let's run that. I'm getting sick of scrolling and pasting this. There's obviously a better way to do this in Zig. It's like write bytes to files or something. What's the documentation? And why we saved on version 11 and not 13. Remove bookmark. We want the searchable documentation though. Is it this one? Yeah. So we want to say, I think it's write bytes to files. Maybe right. I do write. Write bytes. Wherever this is, there'll likely be more stuff. Okay. Let's find it. Okay, it is in IO 327. Oh, that's kind of it. Oh, maybe this is what we want. LON time. How do I write an array of bytes to a file? Oh, this doesn't. This kind of looks correct. Create some file with the file name. Activate some writer thing on it. Okay, this kind of looks promising. This looks promising. Let's see if this. Let's see if we need to adjust this very much. We probably will. Zig writer test. Test output.txt and let's just make this a make this a string, right? Zig writer working. Screenshot stored. Who knows what that's doing? Okay. So now we want to do zig run zig writer test. That's right. Why is this failing? Because it's from an LM, obviously, but why? It's because of this. I don't. Let's avoid that. Okay. Test output. Great. That's what we want. So all we need is just. We only need these 5 lines. Take that, C++. So now we want to do we can still keep this in here as like a debug, but let's set this up. I guess we can set it up here. And then in terms of the file name, Zig should be able to handle whatever file name we want. Equals file. file name equals Brevis image ingest.txt. Okay. Do that. Here we want what is it we want? We want the slice that goes from 0 to the current byte index of what? Of the byte array. So we want this to be byte array 0 to the current byte index. And we just want to try that. Okay. So we're going to do zig run roof.zig. Oh dear. Function cannot return an error. Yes, we understand that. Okay, and now if we cat the Brevis image ingest, that is what we almost repeated the same mistake as last time. It was failing to add the semicolon onto the end. And great, there it is. So, so now we can just make sure the beginning. We'll be able to copy this in. And then next time we can figure out what to do with reading in like a raw file. Okay. Let's see. So time to cut the power of this. So let's put this. Zip, power's gone. Insert the thumb drive. Get out of the way. And then here we can actually get rid of this, like, yes. And then we want to copy that over. And then if we get this working, I think this will be enough for today. Next time we'll then get we'll then write a procedure, see if we have time to translate it into assembly, that then draws the I was going to say take the stuff in the array and draw that to the screen, but we don't have enough space for we're unable to create a stack variable of the appropriate size. I suppose that means we could try calling like an allocator instead and getting that to work. But for the moment, it will be the moment it will be what it is. Okay, and then we want to go into the codecs. Let's just check that it's in here. Oh, we can use this like fun command instead. Fun do Brevis ingest. Yeah, that's what we want. So let's copy it. Yeah, it's a bit annoying. Well, copy. Then let's try and let's like put this into a different file, like texture 2. Make file texture 2 dot LBC. This file copy the current kind of global bug into texture 2. We'll now edit texture 2. And then we can copy in our exported data. Control B. Okay, I think hopefully that's all there. We can now get rid of all of this. Get rid of this. And okay. Now let's try and compile this. Let's create another. Another file. Make file. Texture 2.db. Let's compile in codecs texture 2.lbc and write it to productor texture 2. Why did I call this DB instead of PB? Oh, well. It's not exactly a database. And then let's see what this looks like. Okay, this is great. We can see at the very we have to do this. We can see at the top of the screen the pixels getting drawn from our sprite. Great. So now we just need to spread them out appropriately. But this is I'm happy with this for the moment. I don't given that we seemingly can't create the stack variable that's the large enough size at this point, next time we'll figure, like, we'll do some workaround. I think next time we'll probably end up creating we'll use the allocator to create some region in memory where we can use the current procedure to kind of fill that up. So we can turn this, we can turn all of this into like an init procedure where the pointer we're passing is going to be something made by the allocator, and then next time we can actually then write a function that goes through that portion of memory linearly and correctly adjusts the pixels that we want to draw stuff onto the screen. Okay, I am happy with this progress for today. So let's just like confirm what was happening with the bug before. So we had this like compile crash.lbc, and so if we go into the productor, let's just like make a version of this so that Sam can test it. Make file, like I doubt it's some Python bug or something, but who knows, it could be. So let's do like compile well, if it's a compile crash, it's not actually going to be able to write something. Well, yeah, it's going to be an empty file, but compile crash.pd. Okay, so if we try and do CLB codecs, and it was called like compile crash dot lbc productor compile crash. Yeah, this. Oh, it's because we weren't writing it. I'm naming this incorrectly apparently. Oh, it's compile crash 1. Yeah. So yeah, we'll get this to Sam. Like I'm actually kind of curious if we run like, did some stuff get written to this already? I doubt it, but I don't know how the compiler works. No, nothing got written to it. Okay. So yeah, let's get rid of this then. Kill the power, and let's write a quick message to send to Sam about this. And then that will be the end of the stream. So yeah, so we could say Let's also see what we've done so far as well. Serenum backups. What is it? Serenum 6. It's September the what? The 14th. Wow, thank you Windows for just pulling me out of the thing I was editing. Copy it all over. Okay, and then there's only one way to actually navigate around Windows. So we want to do like Serenum, compiler bugs. What should we call this one? We should make folders for these. Like what did we even call this? Call this like immediate out of range. And where was this immediate out of range? Yeah, this doesn't have like the line in it, but anyway. And it was, what was this called again? I have to find it. We use Sprite. We just opened it in Emacs, it's faster. Compiler, what? Serenum, compiler bugs. This is not, this is where we want to go. So we want to go Serenum backups, the version today, and then it was here, which one? I feel like it was this one. Actually, no. The one we wanted was like. Which one was it? Oh, this is a bit embarrassing. Let's see. Message. Which one was actually causing the fail? It may just be quicker to boot up the Serenum again and check. Yeah, let's just, this is something we've learned to do from now on. Annotate whatever annotate any problematic files like this with some string that we can just immediately search, given that Windows cannot comprehend the file system. I can even put this back in the Serenum. No. Yeah, let's just try this again. Let's just like clear the area of everything. Clear. We'll see if this better not. Of course, whatever. We know how to fix this. Well, I can just do like I can just make this full screen, right? Yeah. So we can now say, I should have remembered that Windows could not remember these labels. Risk, no. Risk V, and now, so we want to do scriptor M global bar compile crash. Compile crash scriptor with this. Well, like I'm now like totally questioning why I was ever using this Elgato even more. This is like way faster. The Elgato just couldn't handle the like. This is the interesting thing. It's like, okay, this is why I forgot. This is why. This is why we can't do it. It is unreadable. What if instead we add it again when it is full screen? Maybe it's okay then. Okay, this is what we're doing from now on. This Elgato capture software is going in the bin. Okay. So we want to say compile crash 1.lv bug. Okay. Okay, so now we can get rid of this. And we do like the backup again. try again. So now it was 22 is our dude. Okay. Yeah, let's like move this to, what do I do? I'm clearly not thinking. 2, and it's just in here. I can just click. That's all that is needed. We don't want to move it. We want to copy it. Like while I'm typing this, I'm like, is Windows gonna error and like I won't be able to finish the file name? I feel like I should only type file names in Emacs. Anyway. Okay. Yeah. So this is. That's just like finally right. Short letter. Using a sensible text editor like Emacs. Yeah, earlier on stream today I tried compiling what you got? I tried compiling the attached file and got the got a compiler crash. The error message generated is attached as a PNG. Yeah, the file like that caused the crash. What should we say? Yeah, do you know what the problem is? I suspect it's the size of the, and what was it again? I suspect it's line, this is like line 33, right? It's line 33. Yeah, is this like throwing the stack out in some way? If so, what's like the limit? And would you, and like could you compile instead describing the like limit to any stack variable. Okay. So yeah, this looks. Yeah, we transferred pixels from a sprite to the screen. We drew them linearly. Whatever. Next time we'll figure out how to draw lots of them everywhere, and then lots of them in an actual sprite, and then we can also then figure out how to read in a file from one program. Yeah, write some logic in this Serenum that will open a file and read through it and read the bytes in it, and then we should just be able to directly you can then build off whatever we do next time by like initially opening that when the program runs, when the program sets up, open this other file, read through the bytes, transfer them to some allocated memory in the stack, and then when we're actually drawing pixels to the screen, just like use that area of stack memory. And then once that's done, we'll be able to add sprites to our game and make it look, transition it from being completely terrible and blank to somewhat crude. But that will be a big improvement. Okay, thanks everyone who stopped by, and yeah, happy programming. I'll see you next time, presumably. Bye.